So questions from the homework? Any before number 9? Yeah, Darian.
I had 7B.
7B?
Like the second to last input thing.
Yep.
When I
Blank completely?
yeah, no, I had when I plotted it, it didn't really work.
Let's see. I look at B, curve, linear. Oh, I can use the fancy math word. Linear or nonlinear? Line or curve? Yeah, no goofy squareds or square. No weird stuff if you really want the... they want me to try a -8, so I would say 0.5 times -8 minus 8. -8 goes with -12. I'm not sure that's quite going to fit on my graph. It might. By the way, if a point doesn't fit on your graph, double check your math, because I won't do that very often, but sometimes it won't. Pick a different point then. So -8, yoink, -12, that's on there. I think 0 goes with -8. Yeah, and 6, half of 6 is 3 minus 8. I think 6 goes with -5, 0, -8. And 6, -5, those look like they're in a line. Now, when they leave it completely blank, what they're saying is, pick some numbers that you want to try that you think will work. Okay. I'm taking half of x. So, Sam, if I'm going to make up input numbers, independent values of my own, I think I'll use even numbers, because finding half of an even number is, no pun intended, even. Is that okay? So, Darian, let's try a number. How about some number between -8 and 0, an even number? I'd go with -4. Sure, that'll work. So it's going to be 0.5 times -4, take away 8, and I get -10. Apparently -4 goes with -10. -4 goes with -10, like that. Let's try an even number between 0 and 6.
I did 4.
Sure. Half of 4 is 2, take away 8 is -6. Is that what you got? Which does work, by the way. It looks like, now, I was initially thinking it was up 2 over 4, which it is, but I think it's actually up 2 over 4. I think it's actually up 1 over 2, up 1, over 2, up 1, over 2, up 1, over 2, up 1, if I want to fill in all the dots in between. Up 2 over 4 will also give you the same line, but if I want the middle dots, it looks like up 1 over 2, 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 up 1 over 2. I think this is the... Boy, that's a terrible drawing. I can do better. Especially if I cheat. I didn't hit erase, Mr. Duick. Come on, pen. Let's try that again. Cheat, careful. Got that one lined up. Eraser off. Click here. Come on, pen. Anyways, pretty close to that. I'll leave it there. I'm close. Was there questions that wanted me to ask as part of that or answer? Okay. State whether, so number 1, complete the table of values, choosing your own input, check. Plot the ordered pairs, check. Sketch the graph, check. State linear and nonlinear, linear. Is that what you're asking about?
Yeah, this was because I was confused because the last dot just didn't look right. So.
It does fit. Looks like it's okay. Yep. Any others before number 9? Number 9. Ooh. Wow. I guess the x is an exponent. Okay. It says, consider the relation described by the equation y equals 1.5 to the power of x minus 2. In grade 12, Naomi, you'll learn that this graph looks like this. You don't know that yet, but it's an exponential growth equation. It says if the input is 4, then the output is, so if I put a 4 in for x, you ready? We have to do the exponent up there first. What is 4 take away 2? 2. This is really 1.5 squared. 1.5 to the, and if you're not sure, you could go to the power of 4 take away 2, because that's what it wants us to do. And you get 2.25. And if you're doing a numerical answer, and there's a couple of those on your provincial exam, you do it like that, kind of. Although I think there's a decimal. Anyways. Is that okay? Yeah. Any others? Going once, going twice? What we're going to be doing today is talking about some very specific, special points on any graph. If you have the homework done, if you want to pass it in block C, and we'll start on the next lesson. Lesson 3, it says, X and Y intercepts. And we start out with a little bit of recalling. Remember, a relation was a connection between two quantities. And if we wanted to represent them graphically, we could represent them with a set of ordered pairs. You guys with me? Is that, you guys have these notes, yeah? You good? We're good? Everyone looked kind of puzzled for a second there. Ordered pairs. What's an ordered pair? Something comma something, where the x means go left, right, and the first coordinate means go left, right, the second coordinate means go up, down. The first coordinate of a set of ordered pairs is the blank coordinate. What letter is the first coordinate? X or Y? X. Also known as the input. And the values of the input are the values of the independent variable. The second component of a set of ordered pairs is the blank. I think that's the y coordinate. And that's the dependent. That's the output. So here's 3 relations, 3 graphs. Which of these is linear? First one. Okay. The other 2 are nonlinear. The third one you don't actually look at until you get to calculus. It's the graph of a circle. But what I want you to notice is, well, let's walk through this. Part A says, list the coordinates of the points where each graph crosses the x-axis. So the x-axis is that one right there. Where does this graph cross the x-axis? Right there. What are the coordinates? What, comma, what? What are the coordinates of that point right there? What, comma, what? Right here? Yeah?
-3, 0.
You are correct. Told you to need a calculator. Where does graph number 2 cross the x-axis? Now, graph number 2 crosses the x-axis in 2 locations. What are the coordinates of the leftmost place where it crosses the x-axis? -2, comma? And what's the second one? What? 3, comma 0. Graph number 3 crosses the x-axis in 2 locations. What are the 2 locations where graph number 3 crosses the x-axis at? Darian. -4, comma 0 and +4, comma 0. Take a look at those 5 points, all of which are where the graphs cross the x-axis. What do they all have in common? What do you see?
0.
What's 0? I got to be careful, not the y-axis, the y coordinate. In fact, now the y coordinate is how high you are. If you're on the x-axis, how high are you? as a number. How high are you? 0 high. That's why they all have a 0 there. What we're really saying, Amber, is, you know what? If you're on the x-axis, I don't know how far left, right you are, but I can tell you I know how high you are. You're 0 high. That's going to give us a trick to find these points. If we let y be 0, if we plug a 0 in for the letter y, we can ask what x's make y work out to 0. That tells me where these are. Say what? Patience. So what do they all have in common? The y, 2 O's, Mr. Duick, coordinate is 0. Part C says, list the coordinates of the points where each graph crosses the y-axis. Okay. Graph 1 crosses the y-axis right there. What are the coordinates of that point? 0, 5. Where does graph number 2 cross the y-axis? Right there, 0, 6. Where does graph number 3 cross the y-axis? 2 locations. 0, 4 and 0, -4. Hey, what do you notice all those have in common? Yeah. Why? How come? Well, if you're on the x-axis, the y-axis, sorry, if you're on the y-axis, I don't know how high you are, but Anthony, I know how far left-right you are. You're 0 left-right. That's the only way that you can be on the y-axis. Oh, and if you're on the x-axis, I don't know how far left-right you are, but I can tell you how high you are. How high? 0. We're going to give these points a special name, and because they involve zeros, Jordan, it's going to make us very easy to do math with them without a calculator, because it's usually going to end up being our 0 times table, and it's going to give us a nice, quicker shortcut to try and graph some stuff. Turn the page. We're going to give these points, Garrett, fancy schmancy names. We're going to call them intercepts. The x-intercept of a graph is where it intercepts, crosses, touches the x-axis. The y-intercept of a graph is where it intercepts, crosses, touches the y-axis. Hey, look up. You don't have to turn back. I'll just show you. That's an x-intercept. That's an x-intercept. That's the x-intercept. That's the x-intercept. That's the x-intercept. That's the y-intercept. That's the y-intercept. That's the y-intercept. That's the y-intercept. So an x-intercept of a graph, you know what? Since that's our new important word, I would underline it, even though it's already bold-faced, is the x-coordinate of the ordered pair where the graph intersects the y-axis. And here's the key idea. The x-intercept occurs where the y-coordinate is 0. The y-intercept is where the graph intersects the y-axis. And you know where the y-intercept occurs? Not where the y is 0. The y-intercept occurs where what's 0? The x-coordinate is 0. So here's the big idea. If I give you the equation and I say to you, Curtis, hey, find the x-intercept. Let every y be 0, replace every single y with a 0, and then solve for x. Figure out what x has to be. Sometimes you'll be able to do it in your head. Sometimes you have to do some equation solving. Or if I say to you, find the y-intercepts, Greg, you know what you're going to do? Not let every single y be 0, but replace every single what with a 0? X with a 0. And solve for y. That's going to give us a nice little shortcut. And because it involves zeros, Amy, it's going to keep the math to a fairly manageable level most of the time. Not always. I got news for you. It's harder than I'm saying, but most of the time. Now, second thing I want you to notice is equations can be written in different forms. We're going to spend a lot of time looking at graphs of lines. We're going to be spending a lot of time looking at graph 1. That equation right there can be written in several different ways. It can be written as y equals 5/3 x plus 5. Turns out that's the same equation looking different as 3y equals 5x plus 15 or 5x minus 3y plus 15 equals 0. We'll be looking at all these different equivalent forms in a different unit. For the time being, the one that I've highlighted, note number 1, can be used to find x and y intercepts of any equation. As an example, number 1. The equation of graph 1 on the previous page is 3y equals 5x plus 15. Algebraically, Brady, that means without graph paper, find the values of the x-intercept and the y-intercept. Now, this is nice, Tyler. I already know the answer. The x-intercept was negative 3, 0. The y-intercept was 0, 5. Let's see if we can prove that. Let's see if we can do this without actually graphing. So you ready? Here we go. What's the first thing that they want me to find, Greg?
The x-intercept.
How do I find an x-intercept? Let y equal 0. See the equation that they gave me? 3y equals 5x plus 15. Replace the y with a 0. Now we're going to do some arithmetic. Jordan, in your head, are you ready? This says 3 bracket 0. When I put a bracket, what mathematical operation are we really talking about? In your head, 3 times 0 is what?
0.
In fact, you're going to get this. 0 equals 5x plus 15. I want to get the x by itself. Now, you may be able to do this in your head, and if you can, great. But just in case you can't, we'll do this the long way. I want to get the x by itself. What side is the x on, the left side or the right side? The right. So for me to get the x by itself, that guy, I need to get rid of this 5. I need to get rid of this 15. How? What's the 5 doing to the x mathematically? Adding, subtracting, multiplying, or dividing? So what's the opposite of timesing or multiplying by 5? Somewhere I'm going to divide by 5. Not yet. Remember I said we do reverse BEDMAS to get the answer when we're solving an equation? We're going to do adding and subtracting first. What's this 15 doing to the x mathematically? Adding, subtracting, multiplying, or dividing?
Adding.
What's the opposite of adding 15? That's the first thing I'm going to do to both sides. I'm going to go minus 15, minus 15. And when I do that, on the left side, I'm going to get 0 take away 15. What is 0 take away 15 in your head? Negative 15. On the right-hand side, the 5x drops down like a domino. And then I have positive 15 take away 15. What's positive 15 take away 15? 0. That was the whole point. Have we got the x by itself yet? No. What's next to the x still? A 5. How do I get the 5 to the other side? How do I get rid of the 5? What's the 5 doing to the x, Simi, mathematically? So what's the opposite or the inverse of multiplying by 5? Are you saying that I would go to both sides, divide by 5, divide by 5? I'd be saying you're correct. When I do that, on the left side, I'll have negative 15 divided by 5. You know what, Jordan? I think I can do that in my head. It's a negative divided by a positive. The answer is going to be negative. 15 divided by 5 is 3. And 5 divided by 5 is 1. I just have an x left by itself. Curtis, you know what the X-intercept is?
-3,
Comma, what was the Y coordinate? Sorry?
0.
Let's see if we're right. Was it -3, comma 0? Woo! I didn't need to graph it. Why is that nice? Because I don't always have graph paper around. It's nice if I can find an intercept by just doing some arithmetic. Let's see if we can find the Y-intercept. Now to find the Y-intercept, to do that, I'm going to let the X be 0. Y, if I'm on the Y-axis, then Greg, I'm 0 left, right. So far, so good. So that means replace every single X with what, Greg? Oh, let's do that then. So I see a 3, I see a Y, and equals a 5, and a 0, a plus, and a 15. Brody, what is 5 times 0? So you're saying this is just the 3Y dropping down like a domino and a positive 15 dropping down like a domino? Now, you could write that, by the way, but if it's just the number all by itself, do we need to put the positive sign in front of it anymore, Brody? We understand it's positive. What am I trying to get by itself, Brody? Yep. How? By? So you're saying if I go divide by 3, I'll get Y equals 5, which means the Y-intercept is when X is 0, Y is 5. Is that what you're telling me? Are we right? Let's go back and check quickly. Whoop. 0, comma 5, right there. Woohoo! Linear equations, which is why we start out with these, Brianna, linear equations tend to be easier to do this with. However, example 2, this can be done with a nonlinear equation. It says the equation of graph 3 on the previous page is x squared plus y squared equals 16. Is it? Yeah. Calculate the x-intercept and the y-intercept. Okay. To find the x-intercept, what do I let be 0? So let's make a little note here. We're going to let y equals 0. When I do that, I'm going to get this. Right? In fact, what is 0 squared, Garrett? I think we're going to get this. X squared equals 16. All right. What number squared equals 16? Something else works too. There is another number that when you square it, you get 16. -4. Oh, can you see that that has to be true from the graph as well? I'm expecting 2x intercept. This is why. So we get 2x intercepts for this graph. We get 4, 0 or -4, 0. Cool. Ty, let's find the y-intercept. How do I find the y-intercept, Tyler? What do I let be 0? I think I do. So Ty, if I hear you, what you're saying my new equation is 0 squared, that's the terrible, 0 squared plus y squared equals 16. Is that what you're saying? In fact, I think what you're really saying is, hey, Duick, y squared equals 16. And then you would say to yourself, what squared equals 16? And you would say, oh, come on. You would say, Mr. Duick, y can be 4 Or in fact, I get two y-intercepts. X is 0, y is 4. Or x is 0, y is -4, which that graph did give me, by the way. How do I find an x-intercept, Alon? Put a 0 in for y. How do I find a y-intercept? Put a 0 in for x. And then solve them carefully. Turn the page. Example 3 says, Lisa purchases a new car for $20,000. Okay. The value of the car can be represented by that formula there. V equals 20,000 minus 1,250t, where V is the value of the car in dollars and T is the age of the car in years. When you purchase a car, what happens to its value as it gets older? Decreases. I think I'm expecting some kind of a graph that kind of looks like that. I think. Yeah? Let's see if we can find some points. So here's the graph that they gave me. The input is t, so it's going to be my x coordinate. The output is v, and the first value they're giving me is 0. I think I can do this one in my head. What's 1,250 times 0, Jordan, in your head?
0.
So this is 20,000, take away 0 in your head.
1,000.
So if I hear you correctly, oops, I added an X. No, that's right. That's a point on this graph. This graph goes through 0, 20,000. Right up there, that's a point on this graph. Let's change colors so it stands out a bit more. That's a point on this graph right there. By the way, it lets you write the ordered pair in this column. If you want to, fine. I can't fit them in there if I write them big enough for you to read. So I'm just cluing in that it's 0, 20,000. But if you want to try and write... Oh, Mr. 0, Mr. Duke. I mean, that works, but I think in the back of the room you have a tough time reading that. Okay. Sticking in a 2 here. Okay, I think I'm going to go to my calculator for a bit for this now. It's going to be 20,000, take away 1,250 times what? Times 2. 17,500. Okay, so on year 2, which is right here, in this line somewhere, it's worth 17,500, halfway between 17,000 and 18,000. You know what? I think that's a point on this graph. Halfway between 17 and 18,000, 2 squares over.
Pardon the interruption. Logan Walker, please contact the office.
Example 4. Or, sorry, third point, when t is 4. I'm going to replace the t with a 4. I'm going to go 20,000, take away 1,250 times 4. Jordan, you know what I get? What? 15,000. Okay, let's add that here. 15,000. At time 4, 15,000. And, haha, I'm spotting a pattern. What pattern do you guys see? Down how many, over how many on the graph? Doesn't it go down 5 over 2? Yeah? So let's see if that holds out. There's my built-in, Brady, my built-in error check. Yes? Yes? Put a 6 in here. So that's going to be 20,000. Take away 1,250 times 6. 12,500. 12,500, which is... Oh, wrong color, Mr. Duke. It says connect the points with a straight line and extend the line. Okay. What are we counting? How are we counting here? What's the pattern, Curtis? How many down, how many over? So look at our graph. 2,500. No, not numbers. Look at my graph. How many squares am I counting down? How many squares am I counting over? Spot the pattern. 1, 2, 3, 4, 5. And then what? So you're saying there's another point right there at 8, 10,000. 5 down. 1, 2, 3, 4, 5. 2 over. 5 down. 1, 2, 3, 4, 5. 2 over. 1, 2, 3, 4, 5. 2 over. 1, 2, 3, 4, 5. 2 over. I think if I extend this, it looks kind of like this. Is that okay, Ashley? Okay, let's answer some questions. So it said connect the points in a straight line, extend the line, done. B. What does the ordered pair 0, 20,000 represent? What does 0, 20,000 represent in English? What does that mean? What amount? When? Ah, Jordan, what?
When it was new.
Cost of the car when it was new. Value of the car when it was new. At time 0, this car was worth 20,000 bucks. As soon as you drive it off the lot, it starts the fancy word depreciating. Starts becoming worth less and less and less and less and less. C says, use the graph to estimate the T-intercept. Now the T-intercept is right there. What do you think that represents? What do you think that means? More specific. Yeah, it's a value, I guess, but more specific. How many years?
16.
So after 16 years, what's this car worth?
Nothing.
Nothing. After 16 years, the car has no longer any value. It's too old. You might get in real life, Greg, you might get like $100 or a couple $100 from it. But trust me, if you try selling a car that's 15 or 16 years old, you're not getting the whole bunch for it.
That might be worth more.
Well, yeah, this, by the way, Darren, this graph is not actually an accurate car graph. An actual car graph, don't write this down, depreciates like this. It's really steep at the beginning. You lose like 30% of your car's value in the first year. But the difference between a car that's 8 years old and 9 years old isn't that much. But the difference between a car that's 1 year old and 2 years old, huge. Then, after about 25 or 40 or 50 years, it becomes a classic, and then it starts to go back up again, but not very steep. So yeah, this graph, we simplified it down. Oh, did I say that we're going to deal with lines the most because they're the easiest ones to start out with? Okay. D says, use the graph to estimate the value of the car after 3 years. Okay, 3 years. 3 years is right here. Yoink, and then across. Hey, what do you think this car is worth after 3 years? About $16,000, maybe a bit more, maybe a bit less, I don't know. What about after 10 years? So here's 10 years, Greg. Yes? How much? I don't think so. Greg? I think 7,500, right? Halfway between 7 and 8 would be 7,500. $14 years. Okay. There's year 14. 2,500. E says, use the formula to evaluate D part 2. So here was our equation up here. What was D part 2? How many years? 10? So if I go 20,000, take away 1,250 times 10, do I get 7,500, which is what the graph seems to suggest to? Yeah. Garrett, did they get the same answer 2 different ways? One via calculation, one from reading a graph? So what do you think the odds are that I'm right if I got the same answer 2 different ways? Pretty good. Thank you for that huge effort on your part. Good. Yeah, I agree. F. When will the car be worth 5,000? Okay, now I'm going to start on the y-axis. It's worth 5,000 here. Read across, read across, read across, read across, drop down, 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 down. When will it be worth $5,000?
12 years.
12 years? Yeah? When will it be worth half the original price? What was the original price? 20,000? When will it be worth half that? How much is half that? In your head, not needing a calculator. 10,000? Told you, buddy. Donk. 8 years? I agree. G says use the formula to verify part 2. So here, this time I'm giving you a value on the y-axis. What do we want? Half the purchase price was $10,000. I would solve this. $10,000 appears for which x coordinate? This is working our way backwards. We could find this. It says $10,000 is equal to 20,000 minus 1,250 times. How many years? So I want to get the t by itself. How would I get the t by itself? Well, what do I see on the same side as the t? I see a negative 1,250. What's the negative 1,250 doing to the t? Adding, subtracting, multiplying, or dividing? Here's what I heard. Subtract. Ooh, multiply. Which one? Why? What's between the 1,250 and the letter T? Nothing. That means times. Yes? It's being multiplied by negative 1,250. That means somewhere along the way I'm going to divide by negative 1,250. Ooh, I also see a 20,000. What's the 20,000 doing? Kira, how do you know? What sign is in front of the 20,000? It's invisible. We never bother writing it, but what's sitting there? A positive, a plus, add. So, to solve this, I'm going to start out doing reverse BEDMAS. I'm going to minus, not 10,000, Mr. Dewick, 20,000. Good gosh. Minus 20,000. Minus 20,000. Hey, how about I minus 20,000? Here, I get 20,000, take away 20,000, Curtis, that's nothing. In fact, the negative 1250 just drops, T just drops down like a domino. But on the left-hand side, I get 10,000, take away 20,000. Hey, what is 10,000, take away 20,000? Brady, how to get the T by itself? By? Close. Yeah, right? So now I'm going to go divide by negative 1250, divide by negative 1250, and when I do that, I'll get the T by itself, and apparently that equals negative 10,000 divided by negative 1250. What is negative 10,000 divided by negative 1250? Don't all rush for your calculators at once or anything. Sorry? Even? Hey, we're right for our answer for part B. We proved it two different ways. It says, complete the following statement to describe this particular relation. The original value of the car is blank. What is the original value of the car? Yeah? Which also happens to be the Y-intercept, yes? Oh, you mean intercepts also tell you the starting and ending thing? Yeah, they're important. 20,000? It depreciates in value by how many dollars per year? I don't think it depreciates by $2,500 per year. I'll give you a hint. You can find the answer in the equation. Yeah. Darn right, it's 1,250. Every year. And has no more value after how many years? How do I find an X-intercept? Put a 0 in for Y. How do I find a Y-intercept? Put a 0 in for X. And they mean something. The tricky part, Sam, is the whole they mean something. There's 1,000,001 graphs out there. I can't teach you what they mean on every single one. All I can say is scratch your brain a little bit, use your head a little bit, and be clever. What's your homework? So your homework, put your name on it. If you haven't already, put your name on it, put your name on it. Marcus, put your name. Okay. Number 1 says find the Y-intercept. The Y-intercept. How do you find the Y-intercept? Okay. Put a 0 in for X and then get the Y by itself. So try all of number 1. Some of them are easy. Some of them are tougher. You'll notice if the Y is already by itself in the equation, it's way easier to find the Y-intercept. Number 2 says find the X-intercept. How do you find the X-intercept? Put a 0 in for Y. So try number 2. Some of these will be a bit tricky. I'm gambling, Amy, that you remember your equation solving, and I'm prepared to do some of these up here again in a second. 1 and 2 all right now. Turn the page. Number 3 wants you to find the X and Y intercepts for each equation and then answer it as an ordered pair. Say what? Try 3A, B, C is good. Skip D. E is good. F is good. G is good. Skip H and I. Number 4, AAA car rental charges $100 per rental plus 10 cents per kilometer. The total cost T in dollars of renting the car can be represented. Oh, there's the equation. T equals 100 plus 0.1 times N, where N is the number of kilometers traveled. So I guess T is sitting where the Y is on the Y-axis, and N is like the X. says complete the table of values. So number 4 is fair game. Do a table of values, connect the dots, and then see if you can answer the questions here. Okay. Number 5 is going to be nonlinear. Let's see if you can handle it. So your equation is h equals negative 5t squared plus 20t plus 25. This is the equation of the height in meters of an arrow shot into the air using a bow. See if you can figure that one. That's a bit beyond the course, but see if you can figure it out, Sam. If you have trouble with that one, that's okay. Let me see what else. 6 is good. Seven is good. Skip 8, skip 9. And the answers are attached, okay? Some of these are tricky, but see if you can handle them all right. You got the rest of class to work on this, folks.